Welcome to this explainer. Look, if you're a public sector leader right now, I know you're feeling that immense pressure to get artificial intelligence deployed across your city's digital infrastructure. But here's the million-dollar question. How do we actually do it safely, without accidentally supercharging the inequalities that already exist? Today, we're unpacking some recent casebooks and research to show you exactly how to scale equitable, gender-responsive AI. We're skipping the abstract theories today. Instead, we're focusing on concrete, implementable systems drawn straight from the India AI Impact Summit and some incredibly comprehensive research on AI transparency.
To really grasp why getting this right is just so incredibly urgent, consider this staggering fact from our source material. 9 out of 10 young girls, specifically between the ages of 6 and 8, associate engineering with masculine skills. Let that sink in for a second. This specific age window is absolutely critical for a kid's cognitive and social development, which means these self-limiting beliefs are forming incredibly early and quickly calcifying into lifelong barriers. So this isn't just a social issue, it's a massive economic one. It literally means our traditional educational tools are failing to tap into roughly half of our potential talent pool before they've even hit middle school.
And that leads us to a really critical question. What happens when our public AI systems are built on historical data that unintentionally reinforces those deep-rooted societal inequalities? Think about it like this. A biased human can really only make so many biased decisions in a single day, right? But an algorithm can make millions of decisions in a millisecond. If we just blindly plug artificial intelligence into our public infrastructure without intensely scrutinizing the training data, we aren't just replicating historical biases, we are scaling them at a speed and volume that is entirely unprecedented.
So here's our roadmap for today. We'll start with the AI equity imperative, then look at a really cool success story called I-10IA and its phygital mentorship model. After that, we'll dive into infrastructure and privacy standards, lay out a local government adaptation roadmap, and wrap things up with an ethical safeguarding checklist.
All right, let's jump right into Section 1, the AI equity imperative and why ethical AI is absolutely essential.
The source text gives us a pretty stark warning here. Without ethical considerations, AI unintentionally reinforces societal inequalities. Honestly, the easiest way to think of an AI model is like a massive mirror held up to our historical data. If the data is biased, well, the reflection is going to be biased. And we know this isn't just some futuristic theoretical warning. The research highlights real-world harm happening right now, things like healthcare algorithms showing racial bias when prioritizing patient care, or facial recognition systems making harmful, legally compromising misidentifications. As public stewards, ignoring this dimension compromises individual rights literally from day one. And because of that, transparency isn't just some nice PR talking point, it is a strict regulatory obligation. We're talking mandates from major legal frameworks like the GDPR and the EU AI Act. Building transparent AI means making absolutely sure that data subjects are fully informed about exactly how their data is being processed. This brings us to a concept called privacy by design. In practice, privacy by design means that before a single line of code is ever written, things like data anonymization and user consent mechanisms are mapped out as core structural elements of the software architecture. They cannot just be bolted on as an afterthought right before you launch.
Moving on to Section 2. Let's look at what this actually looks like in the real world with Atenia II, an incredible phygital mentorship success story out of Peru.
Now, to really understand the Atenia project, we first need to define a pretty novel concept called phygital. As the name kind of implies, it's an approach that integrates physical materials with digital interactions. But how does that actually work in practice? Well, imagine a young girl in a rural area coloring in a physical illustrated book. She then uses a basic, low-cost tablet or smartphone to interact verbally with a custom AI assistant that actually recognizes her progress. It's an incredibly clever and powerful way to bridge the digital divide, especially in areas where internet connectivity is spotty. You're using a familiar, tangible object to kickstart a truly high-tech mentorship experience.
When you look at this deployment in a vocational workshop, Attendia is actively and safely mentoring young girls in STEM. And the crucial part here is that it operates within what's called a closed-loop architecture. In plain English, that just means the local data never leaves the local system. It is absolutely never transmitted up to some massive cloud server owned by a big tech company to train their commercial models. This is how you mathematically guarantee child safety and data privacy. Plus, it utilizes voice-to-text functionality, meaning a lack of reading skills won't block a child from accessing the AI. The system is even programmed to actively redirect any biased conversational prompts to highlight women's competence in STEM, making it a gender-responsive mentor by default. Talk about a game changer.
Okay, Section 3. Let's pivot to the technical reality behind all this.
infrastructure, and privacy standards.
Imagine for a second you're collecting millions of heartbeats, temperature readings, and activity logs from wearable sensors for a smart city initiative. Before a neural network algorithm can ever accurately predict a health anomaly or deliver any kind of public safety insight, that raw, chaotic data has got to be scrubbed clean. It has to be organized, standardized, and entirely stripped of identifying information. If your local government's infrastructure cannot securely sanitize and manage that raw data at step 1, any insight you try to pull out at step 10 is going to be fundamentally flawed and, honestly, legally compromised.
To put the sheer scale of this infrastructure need into perspective, consider this fascinating detail. Stanford University created an entire research facility, the Wearable Health Lab, dedicated strictly to algorithmic data cleaning and pre-processing. Now, why invest so much time and money just into cleaning data? Because garbage in, garbage out is the golden, unbreakable rule of machine learning. For local governments, this means you can't just go out and buy a shiny new predictive algorithm. You have to invest heavily in the foundational data stewardship required to feed that algorithm accurately. This data reality leads right into a major architectural decision you have to make: black box AI versus explainable AI. Think of black box AI like a student giving the correct final answer on a really complex math test, but completely refusing to show their work. In the public sector, that is just totally unacceptable. When a government deploys an algorithm to assist with credit scoring, policing, or healthcare, we absolutely require explainable AI or XAI. These are systems specifically designed to essentially show their mathematical work, ensuring that a human auditor can step in, read the logic, and verify that the decision-making process isn't biased or flawed.
Which brings us to Section 4, the Local Government Adaptation Roadmap. How do we actually adapt this for your city?
Based on our case studies, here's your highly actionable, step-by-step operational flow. Step 1. Assess your data infrastructure. Do you actually have the secure cloud environments needed to pull this off? Step 2. Establish universal validation standards. You've got to create consistent rules for how data is collected across all your public agencies. Step 3. Integrate explainable AI. You need to mandate that any vendor providing a software tool to your city also provides transparent logic for its outputs. And finally, Step 4. Implement human-in-the-loop oversight. AI in the public sector must be treated as a decision support tool, not a fully automated decider. Human experts always need to be there to review and validate those automated recommendations.
Finally, let's wrap up with Section 5, the Ethical Safeguarding Checklist.
Before you launch anything to the public, your evaluation process has to include these 5 non-negotiables. First up, consent-aware data pipelines, where users explicitly opt in. Second, gender disaggregated datasets, which prevent the AI from just defaulting to male-dominated norms. Third, continuous bias mitigation audits. You can't just test an AI once and call it a day, you have to monitor it in real time. Fourth is anonymized and encrypted data storage. And fifth, trauma-informed user interfaces. This one is so important. It means if a citizen is using a municipal AI portal to report a health crisis or a domestic issue, the chatbot's language and prompts are specifically designed to be empathetic and supportive. You want to completely avoid sterile robotic questioning that might re-traumatize them.
So, we'll leave you with this final provocative thought to consider as you shape your own digital public infrastructure. Are you prepared to implement the necessary safeguards to ensure your AI deployments actively empower your community, rather than exclude them? Look, the technology certainly exists. The frameworks have been beautifully proven by projects like Autenia, and the regulatory mandate is clearer than it has ever been. It's really up to us, as policymakers, to build the transparent, equitable infrastructure that our public deserves. Thanks so much for joining me for this explainer.